This video is going to be part 2 of our discussion on multiplicity. So, multiplicity of zeros and part 2. So here's a quick review on multiplicity. If a zero of a function, so an x-intercept, if it repeats or occurs, either way you want to think about it, an even number of times, then it bounces or touches off the x-axis. But if it repeats or occurs an odd number of times, then it would pass through the x-axis. So just to make sure we're all clear, if the number occurs an even number of times, so like it's 2 times, it happens 4 times, and etc., then it would touch or bounce off the x-axis. If it occurs 1 time or 3 times or 5 times, something like that, then it would occur, or then it would pass through the x-axis. So let's take a look at an example that is in the study guide. It's number 11, and it says create a rough sketch of a polynomial that meets the following requirements. And so it says the end behavior is f of x goes to infinity as x goes to negative infinity. F of x goes to negative infinity as x goes to positive infinity. And so the zeros are 2 and negative 3, so I'm going to put those on my graph. So there's negative 3, and there's 2. And it says the graph has a multiplicity of 2 at the 0, negative 3, comma 0. So that would be this point right here. That would be my place where it's going to have a multiplicity of 2. So, oops, sorry about that. And so what we've got going on here is we're going to have our 0 at negative 3, and based off of what we saw, it will actually bounce off that place, but then at 2 it's just going to pass through. But we have to take care of the end behavior. So it says the graph f of x goes to positive infinity as x goes to negative infinity. This is as it moves to the left, and this one is as it moves to the right. So if the graph is going to positive infinity, that means the graph is coming and pointing up to the left. And if it's going to negative infinity to the right, that means it's pointing down to the right. And so we're going to draw this, and it's going to bounce at negative 3 because it says it has a multiplicity of 2. That's an even number. It's going to bounce, and then it's going to go up, and it's got to come back to 2, and then it's going to actually pass through it, and I'm going to make it meet that arrow right there. And so the graph is going to look something along those lines. So that it has the right end behavior, it has the right zeros, and it follows the multiplicity. If somebody were to ask us to give a graph of this, we'd say f of x, or not a graph, but to give a function of it, we would say f of x equals, and since the zeros are 2 and negative 3, we know we're supposed to write that as x minus 2, the parentheses it would come from, and x plus 3, the parentheses it would come from. And now we just have to get the exponents and the end behavior right. So if it has a multiplicity of 2 at negative 3, 0, then that means I'm going to make that squared. And if we're going up to the left and down to the right, that means there was a negative leading coefficient. So you should put a negative number in front of that. So me, I'm just going to put the negative 1. I don't actually have to write 1. I just put negative. And that would be my answer. If I wanted to say, hey, there's a actual function. If I wanted to just give a graph, the graph would look like that, the one in purple. But if somebody asked for an equation, it would look like the one there in red. All right, hope that helps. Have a great day.